Good day and welcome to One-on-One Maths Private Tutors. We start on this topic, transformation. The syllabus requirements for ZIMSEC O-Level and Cambridge O-Level and IGCSE are the following. The similarities are translation. We find translation in both syllabuses, reflection, rotation, and enlargement. These four topics are in both syllabus, but for ZIMSEC goes on to stretch and shear. So we shall look at these for only ZIMSEC, but for Cambridge, we will look only on the four: reflection, rotation, translation, and enlargement. The language of transformations. When a shape is transformed, the original shape is called the object and the new shape is called the image. A transformation maps the object onto the image. The vertices of an object are labeled A, B, C, and so forth. Corresponding vertices are labeled A dash, B dash, C dash. Anything that stays the same when a transformation is performed is invariant, which means it doesn't change. Now we look at reflection. Reflections are carried out in a mirror line. So we have to define the mirror line, equation of a line for reflections. In a reflection, corresponding points are the same distance from the mirror line, but on the opposite sides. In a reflection, corresponding points are the same distance from the mirror line, but on the opposite side. The object and the image are congruent, which means the size is not changed, but the image is reversed. Points on the mirror lines are invariant points under a reflection. So points that are on the mirror line will not change. In this diagram, the shape has been reflected in the line PQ. So we have our line PQ. So this is our object reflected into this line to give an image here. The perpendicular distance of A to the mirror is equal to the perpendicular distance of A bar to the mirror. So this distance is the same as that. Also, this distance here is the same as that distance. And this distance here is the same as that distance. And if we draw a line from D to D bar, we'll see that this distance from the mirror line to D bar is the same as the distance from the mirror line to D. Let's look at this example. Reflect the trapezium in the line y is equal to 1. So first we need to draw the mirror line, which is y is equal to 1. So the line y is equal to 1 is this line here, y is equal to 1. So we need to reflect this shape in the opposite side of the mirror line. Let's label our trapezium A, B, C, D. Now, the perpendicular distance of D on this side should be equal to the perpendicular distance of D on the other side. So we can see this is 1 square. So D will be 1 square from the mirror line in the opposite side, which is this side. So we have our D bar there. Our C is 1, 2, 3 squares from the mirror line. So we will also count 1, 2, 3. So this is our point, C bar. Then we go to B. The perpendicular distance of B from the mirror line is 1, 2, 3. So from the mirror line on the opposite side of the mirror line, we count 1, 2, 3. This is our B bar. Then A is 1. From the mirror line on the opposite side, we also count 1. Then we have our A bar. Now all we have to do is to join these points, A to D, B to A, C to B, and D to C. We have our object there and our image. That is our answer. Let's look at this question. Reflect this shape in the line y is equal to minus x. We are given the line y is equal to minus x, and this is our object. So we can label the vertices A, B, C, D, E, F. Now we draw perpendicular lines to the mirror lines from our vertices. So we start with A. We can see A is right on the mirror line. So we can say A is invariant. We said points on the mirror lines are invariant points under a reflection. Their position will not be changed. So our point A also becomes our A bar. Now for our point B, we can see it's this half diagonal and a full diagonal. So we go behind the mirror line, half a diagonal and a full diagonal. So our point is here. So we have our B bar. For our C, we have one diagonal, two diagonals, and a half. So behind, we take this half diagonal, one diagonal, and two diagonals. So it's this point there. For E, we have one diagonal and two diagonal in front of the mirror line. So we take also two diagonals behind the mirror line. 1, 2. So this is our point there. And it's D bar. This is C bar. So we have C bar there. For our E, we have one diagonal and half a diagonal. So we take half a diagonal and one diagonal there. So our point is there. Okay, let's enlarge it a bit. One diagonal, half a diagonal, half a diagonal, one diagonal. For F, we have half a diagonal in front of the mirror line. We take half a diagonal behind the mirror line. Our point is here. So we have F bar there. Now we join corresponding points. A is joining to B. A bar will join to B bar. B bar will join to C bar. D is joining to C. D bar will join C bar. This point here is E bar. So we have E bar there. E is joined to D. So E bar will join to D bar. E is joined to F. So E bar will join to F bar. Then we have A joining to F. So A bar will join to F bar. So that in orange is our image. So our object has been reflected into this line to form this image. And as we have said, A is invariant. When you have drawn a reflection in a sloping line, check it by turning the page so that the mirror line is vertical. So we want this mirror line to be vertical. Then you can easily see if it has been reflected correctly. Okay, let's do that. So we're going to rotate this to make our mirror line vertical. When we rotate this so that the mirror line is vertical, we can see this has been reflected there. And we were told the object and the image are congruent, which means they are exactly the same shape, but the image is reversed. Look at this orientation, it's now reversed that side. Points on the mirror line are invariant. A is invariant, so it's carrying out all the properties of a reflection. Thank you.